Funct.println takes as many arguments as you feel like giving it. 1, 3, 10. It does not care. Functions that accept a variable number of arguments are called variadic. You have been using them since the first video without thinking about it. Now you get to write your own. And there is a nice symmetry in the syntax that makes the whole thing click once you see it. You make a function variadic by putting 3 dots before the type of the last parameter. Nums ... int. That means any number of ints. And here's the part that makes it simple. Inside the function, nums is just an ordinary slice of int. There is no special variadic object to learn. You range over it exactly like any other slice, because that is exactly what it is. Go builds that slice for you, out of whatever arguments the caller handed over. 3 arguments gives 6. 2 arguments gives 30. And no arguments at all is perfectly legal. When you call it with nothing, nums is an empty slice. The loop runs 0 times, total stays at 0, and we get 0 back. Notice we did not write a special case for that. There is no if nums is empty check anywhere in the function. An empty slice behaves exactly like a slice. With things in it, it just has nothing to iterate. That is a theme in Go, and it saves you a lot of defensive code. A variadic parameter can follow ordinary ones. It just has to come last. So join takes a separator, and then any number of strings to join together. The separator is a normal, required parameter. You always pass it. Call it with a dash, and the words go, is, and fun, and you get go dash is dash fun. 2 restrictions. Only one variadic parameter is allowed, and it must be the final one. The reason is straightforward. The compiler has to know where your fixed arguments stop and the variable ones begin, and it can only work that out if the variable ones are at the end. Now the other half. What if you already have a slice, and you want to hand it to a variadic function? You put the 3 dots after the argument. Values ... That means use this slice as the argument list. 4 plus 8 plus 15 plus 16 is 43. And the second line takes just the first 2, 4, and 8, which gives 12. We will cover that slicing syntax properly in the next module. Without the dots, you would get a type error. Go would think you were passing one slice of int where it expected individual ints. So the same 3 dots appear in 2 places, with mirrored meanings. In a declaration, before the type, they pack the arguments into a slice. At a call site, after the value, they unpack a slice back into arguments. Packing and unpacking. Once you see it that way round, you will never have to think about which is which again. Here is a detail worth knowing before it bites you. This function sets the first element to 0. Nothing surprising. But after we spread values into it, values itself has changed. It is now 0, 8, 9. The last video told you arguments are copies. So what happened? When you spread a slice, the function receives the same underlying array, not a fresh copy of it. The slice header is copied, but the data it points at is shared. This is slice behavior, not variadic magic, and the collections module explains exactly why. It is the single most important thing to understand about slices. And note the contrast. If you had called 0 first, with 7, 8, 9 written out individually, Go would build a brand new slice for the call, and there would be nothing of yours to modify. The standard library is full of these, and now you can read their signatures. Println takes any number of values, of any type. That any is Go's word for a value of absolutely any type, and you will meet it properly in the interfaces module. Printf takes one fixed parameter, the format string, and then any number of values after it. Fixed first, variadic last, exactly the rule we just covered. Append is variadic too, and it is probably the most used function in the whole language. You will meet it in the next module. And here is a useful counterexample. Strings.join is not variadic. It takes a slice. That is a deliberate choice by its author. Join wants precisely one list of things, so it asks for a list. Being variadic is not automatically better. Your turn. Write a function called longest, which takes any number of strings and returns the longest one. If several tie, return the first. With no arguments at all, return an empty string. Pause and write it. Here is the answer. Words, string, so any number of strings. Best starts as the empty string, and we only replace it when we find something strictly longer. That word strictly is doing the tie-breaking. Because we use greater than rather than greater than or equal, a later word of the same length never displaces an earlier one. The first one wins, exactly as asked. And the no arguments case needs no special handling at all. The loop runs 0 times and best is still the empty string we started with. Call it with cat, elephant, and horse, and you get elephant. That is variadic functions. 3 dots before the type in a declaration, 3 dots after the value at a call site, and a plain slice in between. Next up, functions stop being things you call and start being things you can store in a variable, pass as an argument, and return.